Let's talk about unit analysis. This is something that you probably won't formally learn for a couple of years, but I think it's good that you see it now because you're going to be using it all the time. So for the first question here, it says that you drive at a constant speed of 65 kilometers per hour. Your trip takes 2.5 hours. How far was your trip? Okay, so what we would say is, all right, I drive at 65 kilometers per hour. I want to know how far the trip was. So I want kilometers as my final answer. So I want to get rid of the hours, right? I want to get rid of h. Well, h is on the bottom. So to get rid of it, I would multiply by h. So what I do is multiply by the number that has hours as my unit. So the 2.5 hours. So I multiply by 2.5 hours. What happens? H on the bottom and top cancel because h divided by h is just 1. And I'm left with 65 kilometers times 2.5, which is 162.5. And the only units that are left are kilometers, so my answer here is kilometers. So even if you're not really sure why you're multiplying numbers together, or why you're dividing them, or why you're doing what you're doing, if you rely on the units, most of the time you're going to get your right answer, because you know the units of the answer you're looking for, and you know the units of the terms that you were given. Let's try another one. You drive at a constant speed of 65 kilometers per hour. Your trip is 86 kilometers. How long is the drive? Okay, so this one, the question is saying how long is the drive? So our final answer should be in hours, right? So if we want to get hours, how do I set this up? Well, I have a speed of 65 kilometers per hour, so there's an hour in there, and I know the length of the trip is 86 kilometers. So I can use those kilometers to cancel each other out and end up just getting the hours. So instead of writing 65 kilometers per hour, I want the hours to be on top. So I'm going to write 1 hour per 65 kilometers. Because that's really what that's saying, right? It's saying that you can drive 65 kilometers in 1 hour. So I could say instead that it's 1 hour for every 65 kilometers. You can just flip it, just like that. You then multiply it by 86 kilometers, because kilometers on the bottom and top, they'll cancel out. And I'm going to be left with, when I do 1 divided by 65 times 86, when I do that math, it's the same as 86 over 65, which is 1.32, and I'm left with hours. Because the kilometers cancel, I'm left with hours on the top. And that's how I get my final answer. So it's a really nice trick here that you can use to always get the answer you're looking for. Because you might try to do, 65 times 86, or 65 divided by 86, trying all these things, and then you just put your units on that are correct, but you're not going to get the right answer. So if you let the units guide you through the process, that's a good way of at least giving yourself a little bit more information and a little bit of a better chance to get the correct answer. So for this question, if we wanted to, instead of flipping that first term, what we could have done is divided by it, right? I could have said 86 kilometers divided by 65 kilometers per hour. And the kilometers would have canceled, and you would have got 1.32, and the units would have been hours. And it's kind of confusing as to why they're hours, because it's like the hours are on the bottom of the fraction. But when you have a term on the bottom of the bottom, right, the denominator of the denominator, that puts it back on top. And the proof is up here, the work we did previously, right? The proof is right up here. So if you want to do it this way, you can. I just find that some people struggle to remember that if you have a number down here being divided in the denominator, that comes back to the top and ends up being your units. So because some people forget that, I like to do it this way, where you just flip that first term and then multiply them, but it's completely up to you. Another way you can think about this is 86 kilometers. Instead of dividing it by putting it over 65, you can say divided by 65 kilometers per hour. Put the hour under the whole thing like that. And then if you remember our work from fractions, you're allowed to change division to multiplication if you flip the fraction. So you get 1h over 65 kilometers. I put the 1 there because there's always a 1 there, right? Technically this is 1h, so you put 1h on the top. And then that's the exact same step that we did originally, right? 86 times 1 over 65, 86 times 1 over 65, it's the exact same thing. So there's so many ways you can manipulate this to get your answer. It just really depends on what you're comfortable with. So that's why I say at the end of the day, just make sure your units are going to cancel out and you're going to get the units of the answer that you're looking for. Because that can guide you to the right answer if you're unsure about how to divide the numbers or how to multiply or what you're supposed to be doing. Follow the units. That is my advice. Always follow the units. Let's do another example. let's say you want to convert 20 kilometers per hour to meters per second. Now you might be able to do this in different ways, but I'm going to use unit analysis. So I have 20 kilometers per hour. I want to change my kilometers to meters. So I have to multiply this by a conversion factor, right? So I know that there's 1,000 meters in a kilometer. So I could put 1 kilometer per 1,000 meters, but I want the kilometers to cancel. So I want the kilometers to be on the bottom. So I'm going to put 1,000 meters on top and 1 kilometer on the bottom, because now kilometers cancel and I'm left with meters on top, right? So right now I have meters per hour, really. So I'm halfway there. Now I want to get rid of hours. So I need a conversion for hours to seconds. Well, I want my hours to cancel, so I'm going to put my hours on the top and my seconds on the bottom. So how many seconds are there for every hour, right? Well, for 1 hour you have 3,600 seconds. And you could figure that out because there's 60 seconds in a minute and 60 minutes in an hour. So 60 times 60, that gives you 3,600. So you can do that as well. Now your hours are going to cancel. And look, I'm left with meters on top and seconds on the bottom. So I know that when I calculate this, it's going to give me the right answer. That's the trick. So 20 times 1,000 divided by 3,600. So you're going to get 5.55 meters per second, approximately. This decimal keeps going. We just stopped it there at 5. Okay, so that would be your final answer. Let's do another one. What if you want to convert 100 liters per minute to milliliters per second? Okay, so I have 100 liters per minute, so minutes on the bottom. I want to cancel the liters. I want to change the liters to milliliters. So I have to multiply this by another conversion factor. So I'm going to put 1,000 milliliters, because I want milliliters on top, for every 1 liter, because now the liters cancel, because there's one on the top and one on the bottom. And again, the reason I'm allowed to introduce this fraction is because it's just like multiplying by 1, right? This fraction is equal to 1, because 1,000 milliliters and 1 liter are the same thing. So if you do something divided by itself, it's just 1, right? That's why I'm allowed to do this. So I multiply by that. And now I want to change minutes to seconds. So I have to have minutes on top, so that it cancels with the minutes on the bottom, seconds on the bottom. So what numbers do I put here? Well, for every 1 minute, there's 60 seconds. So I could just do that, and then my minutes will cancel. And look, I'm left with milliliters per second, which is what I want. So you multiply these numbers together, 100 times 1,000 divided by 60, and you get 1,666.6. That continues, keeps going, and the units there are milliliters per second. And that's your final answer.